Frequency holding ground number 5J2. Now I'm going to explain the topic about ALOHA. It has derived from a compound of the Hawaiian words. Aloha means share, Ha means essence of life. Development of ALOHA network was begun in 1968 at the University of Hawaii under the leadership of Norman Abramson. The goal was to use low-cost commercial radio equipment to connect users on Oahu and the other Hawaiian Islands with a central time-sharing computer on the main Oahu campus. ALOHA became operational in June 1971, providing the first public demonstration of a wireless packet data network. Although ALOHA was designed for wireless communication, there were two other media available for the application of an ALOHA channel. There are cables and satellites. In 1970s, ALOHA random access was employed in the widely used Ethernet cable-based network and then in the satellite network. Contention is a media access method that is used to share a broadcast medium. In contention, any computer in the network can transmit data at any time. That is on the basis of first come first server. The ALOHA Net solution was to allow each client to send its data without controlling when it was sent, with an acknowledgement or a transmission schedule used to deal with collisions. ALOHA is of two types, pure ALOHA and slotted ALOHA. Now we are going to see the pure ALOHA. Whenever a station has data, it transmits. That means frames are transmitted at completely arbitrary time. Sender finds out whether transmission was successful or experienced a collision while listening to the broadcast from the destination station. Sender retransmits after some random time if there is a collision. Here, the frames that are coming from different stations having the collision duration time. So these are sent after sometimes going the before one. Here it is the procedure for pure ALOHA protocol. Initially the K value is 0 and we send a frame from the station and we wait for a propagation time 2 times of its normally it had. Acknowledgement, if an acknowledgement is received, the process completed that the frame came from the station and send it in a proper way. If not, the K is increased by 1 and its K value is greater than by the K maximum value. Normally the K maximum value is 15. It is greater than it. The K value is greater than K maximum. We can get out from this loop. If not, we choose a random number r between 0 and 2 power k minus 1. And then we need to wait for a back of time that is r into tp. Analysis for pure ALOHA. Here T notations are TF frame time as signifies average number of successful transmissions. We will make the following assumptions. All frames are of constant length. The channel is noise-free. The errors are only due to collisions. Frames do not queue at the individual stations. The channel acts as a Poisson process. Here we are having the formula in a Poisson way. That is the probability of good transmission is it is having the formula in a Poisson way. That is we can see here. Since S represents the number of good or succeed transmissions per frame time and G represents the attempted transmissions per frame time, then we have S is equals to G into probability of good transmission. Here, vulnerable time for pure ALOHA is we are having the vulnerable time that is from T minus TFR to T plus TFR, and here the collisions are B ends and A collides with A beginning, and A ends or collides with C beginning. The probability of having K arrivals during a time interval of length T is given by Pk of t equals to lambda t whole power k into e power minus lambda t by k factorial, where lambda is the arrival rate. The vulnerable time for a successful retransmission is 2 into Tf. Collision probability is increases. Here we can put that small t is equals to 2 into Tf. Therefore, we can get S is equals to g into 2 e power minus 2g. For pure ALOHA, the probability of a successful transmission is e power minus 2g. Expected number of transmission is equals to e power 2g, which means that a small increase in the channel load, that is g, can drastically reduce its performance. The throughput for pure ALOHA is S is equals to g into e power minus 2g, and its maximum throughput is 0.184, where g is equals to 1 by 2. The ALOHA is an unstable protocol. Here is the graph between the load versus throughput, which is having the G is equals to 1 by 2 and S is equals to 1 by 2 into E, and having only about 18%. Slotted ALOHA was invented to improve the efficiency of pure ALOHA, as chances of collision is pure ALOHA are very high. In slotted ALOHA, there is still a possibility of collision if two stations try to send at the beginning of the same time slot. Slotted ALOHA still has an edge over pure ALOHA, as chances of collision are reduced to 1/2. Assumptions made in slotted ALOHA. All frames consist of exactly L bits. Time is divided into slots of size L by R seconds. Nodes start to transmit from only at the beginning of the slots. The nodes are synchronized so that each node knows when the slot begins. If two or more frames collide in a slot, then all the nodes detect the collision event before the slot ends. Processor for slotted ALOHA. While there is a new frame A is to be send frame A at a slot boundary and wait for the acknowledgement. If after some time acknowledgement is received, successful transmission of frame is done. If there is a collision, the node detects the collision before the end of the slot with a random amount of time and to go to the one. And here it ends. The node retransmits its frame in each subsequent slot with probability P until the frame is transmitted without a collision. The vulnerable time for slotted ALOHA protocol. Before we have seen this, A's beginning is having collision with B's ending, but here is not like that. A completely collides with C at the beginning and also at the ending. It is treated as the slotted ALOHA. Note that the vulnerable period is now reduced in half. So we are having that small t is equals to capital TF. So we are having that throughput maximum is SC is equals to G into e power minus G. The probability of no collision is given by P of 0 equals to e power minus 3. And throughput is SC equals to G into P of 0 equals to G into e power minus 3. The maximum throughput of slotted ALOHA is S max equals to 1 by E, that is 0.368. It is having 36%. Rising G reduces empties but increasing collisions exponentially. Expected transmissions E equals to e power G, where G equals to 0, then 1 transmission, G equals to 1, then 2 into X transmissions have been done. Small increase in load, big decrease in performance. The pros and cons of slotted ALOHA. The pros are single active node can continuously transmit at full rate of channel. Highly decentralized. Only slots in nodes need to be in sync. Simple protocol. Cons. The cons are collisions, wasting slots, idle slots. Nodes may be able to detect collision is less than time to transmit packet. Clock synchronization. The throughput versus offered traffic for ALOHA systems. It is between the pure ALOHA and the slotted ALOHA. Pure ALOHA is having 0.18 for throughput time, and the slotted ALOHA is having 0.368 throughput time. And overall, we can say that ALOHA is one of the random access protocol implemented at link layer. Chances of collisions are more in pure ALOHA as compared to slotted ALOHA, but still it is least efficient as compared to other random access protocol such as CSMA. These protocols work efficiently when there are less active nodes. Modified versions of ALOHA are being used in some services such as mobile slotted ALOHA. Thank you very much.